Thank you, everybody. My name is Badri Rajasekar, CTO of TokBox. And what I'm going to be talking about today is interactive broadcasting. I think this is really the next frontier in sort of real-time communication. And this clicker is a little slow. If you actually look at the WebRTC ecosystem, you've seen a lot of people talk about WebRTC. And one interesting thing is as the ecosystem matures, you are seeing increasingly more and more sophisticated use cases which are being built on WebRTC, right? The first wave of real-time communication, and for those of you who have been actively using WebRTC, when WebRTC first came out, it was mostly a peer-to-peer protocol. And so essentially there was a whole bunch of one-on-one use cases which are unlocked, whether it's sort of doctor-patient or sort of a social use case where one person is calling another person. And as the technology sort of matured, you had a whole bunch of ecosystem vendors who came up with server software which enabled people to do conferencing or sort of multi-party. And this, I think, is what the second wave of real-time communication was, where it sort of unlocked this group conferencing use cases, small classrooms, online sessions, so on and so forth. And really, I think as those cloud infrastructures are actually sort of maturing, we are at the cusp of what I call the third wave in sort of real-time communication, which is sort of interactive broadcasting. And it's going backwards. But something really interesting is actually happening in this space. And in order to understand what is happening, I think it's useful and sort of illustrative to look at some of the broad trends which are happening in real-time communication. The first thing is user-generated content is getting democratized, right? People have smartphones. You can very easily sort of generate and capture data. And whether it's YouTube or whether it's Twitch.tv or Periscope or Meerkat, it's becoming easier and easier to sort of generate content. And there's a democratization of user-generated content. And the second interesting thing which is happening is the user itself is becoming part of that interesting content, right? There's a whole bunch of interesting conversations where people are talking online, and that content itself is sort of interesting. And the third thing I would say is that sort of how people consume media and how media is sort of distributed is also radically changing. Here's a very simple example. If you actually look at the average time an adult in the US actually spends consuming online video, that number has gone up 4x between 2011 and 2015 relative to other things people sort of do online. And I think what all of these interesting trends have brought about is this era of interactive broadcasting. And that's sort of a natural evolution in terms of how people interact and have dialogues around content, right? I was originally going to show a cricket image, but I thought I'd better not get into trouble. But here's an interesting example from Instagram. There's a static image, there's some sort of a football game which happened. There's a whole bunch of people who are actually talking about it a little bit asynchronously. And if you actually think about it, as this content actually is becoming more and more real time, the conversations around it and how people engage with that content is also becoming real time, right? Here's a simple example of how that asynchronous conversations are moving to a much more synchronous world. This is an example of an application which is called blab.in. Here's an interesting use case where there's a whole bunch of people who are actually talking about a topic, and you see the content is actually real time. And there's a bunch of people who are actually viewing this, and they are also interacting. And the interesting thing I want to point out is you see this call-in button. So anybody who's actually viewing this real-time experience can call in and actually participate in that experience itself. So the fundamental point I'd like to make is that sort of the nature of interactivity is changing, and people are less and less becoming passive consumers of digital content. And I think we are in an era of participatory viewing, where people and consumers and people who are viewing it are actually becoming part of the content itself. And I think this is sort of a very interesting trend which is happening. And if I were to make a bold statement, it would be that the era of how people consume video and how broadcasting happens is going to be radically transformed by various underlying technologies like WebRTC. And we see this happening across a whole range of verticals, right? Here's an example with Fox Sports. Essentially, it's sort of it's a college football game. The game happens. After the game, the athletes are being interviewed. There's a whole bunch of people who are actually watching this, and the people who are watching can jump in at any time and participate and ask a question or go live on video. Again, we see this happening across a whole slew of other interesting verticals: online classrooms, sort of music concerts, so on and so forth. So I think it's a very interesting time in sort of real-time communication. The clicker won't move forward. But I think the interesting thing is, as the technology matures, how do we push enabling technologies like WebRTC and other technologies to actually build and architecturally make these experiences possible? And the one framework I think it'll be really useful for folks to actually think about how to build this is this concept of people being on stage and people being off stage. And the simplest example is this room. Now, if I call Sahi or Sam to come and talk to me, we are actually having a conversation on stage, and there's a whole bunch of people who are viewing this off stage, and the same paradigm can be used in sort of real-time communication, right? The interesting thing with this model is the people who are on stage need to be in a very low latency, highly interactive environment, because they're all talking to each other and they need to have really low latency. The people who are watching are traditionally in a much more higher latency environment. This is like anybody at home who's watching a live television feed of a game or what have you. It's not really that live. There's some amount of delay in how that feed is delivered to you. But increasingly the challenge or the opportunity, the interesting model is, how do you make more and more of the people off stage to be much more in a highly interactive, low latency environment, so that when they want to participate and they want to go off on stage, they get to do so in sort of a seamless manner from an experience point of view. So if you actually think about all the current architectures, none of those really solve this problem well. So let's go through some example architectures. The first approach is the streaming CDN model. This is the traditional model when one stream basically is being pumped into the CDN, and the CDN then redistributes that stream to a whole bunch of viewers, right? And the problem with this model is traditional CDNs are not designed for interactivity or low latency. CDNs are designed for high scale and distribution, right? I want to take one stream, it's like a live stream, I want to deliver it to thousands of people. That's essentially what CDNs are designed to do. And so interactivity is not really the strength of a CDN. Another model which exists today, which a lot of people use, is what I call the MCU model. This is the traditional conferencing model. If you did a video meeting or what have you, this is how things work. You have a centralized unit. Each person on stage is publishing a stream to the MCU, and everybody who's subscribing actually get a merged composite stream. So if you're in a Cisco telepresence conference, you will see all the participants, but you are getting a single stream. The problem with this approach is that essentially the MCU is actually doing transcoding. The fact that you have to collect multiple streams, decode them, mix them, introduces a degree of latency, right? And again, the other problem is because of the computational cost, you are sort of limited by the amount of streams a single box can handle. Let's say this MCU can support 200 streams. You cannot have a broadcast of more than 200 people, right? And the WebRTC model is something called an SFU, or a selective forwarding unit. Think of this as an MCU. This is sort of a server, but the server, instead of actually mixing or compositing the streams, will essentially route individual streams to different participants. In this case, if there are 3 people on stage, each of them publish a stream to the CDN, to the SFU, and they actually subscribe to all the other participants' streams. And anybody who's off stage will subscribe to 3 streams in this case, because there are 3 participants on stage. What this model does is actually gets away from sort of some of the computational cost and latency introduced by MCUs, because it's much more easier to just route streams. And it also provides low latency, so you can have highly interactive, low latency environment. The two problems with this current approach is, again, you're trading off computational cost to bandwidth. In this case, each participant is consuming more bandwidth because they have to subscribe to 3 streams instead of 1 composite stream. And secondly, again, you're limited by the capacity of 1 box, right? And if you actually think about all of these 3 options, none of these are actually designed to solve the large-scale interactivity problem. They're all designed to do very specific things very well. But really, what is required to do large-scale interactivity is something way beyond. And I think it's actually a hybrid approach of all of these architectures, where not each of these are merely building blocks which need to be put together in sort of new and interesting ways. The diagram looks a little bit complicated, but it's actually an interesting way to think about how to put all of these components and building blocks in order to enable sort of a highly interactive, large-scale session. And one interesting architectural way I would sort of encourage all of you guys to think about it is actually there is a low latency on-stage portion, and you got to split the off-stage portion into 2 pools. One with very low latency, so there's a whole bunch of low latency subscribers, and there's a bunch of relatively higher latency subscribers. In this case, there are 2 participants who go to an SFU. There's 1 person here, but presumably there could be several hundreds of these people who are actually directly connected to the SFU and who are just viewing, and they are in a very low latency environment. The MCU is also a client to the SFU and gets the streams in relatively real time. The MCU then mixes the streams. Traditionally, WebRTC media is over SRTP. You do some sort of protocol translation. You move to HTTP live streaming, pump to a CDN. The CDN can then distribute. And the interesting thing in this model is there are very interesting ways by which all of these components can be scaled in a very cost-effective manner. And what that leads to is the ability for people to be in a very low latency environment. Let's say this participant actually wanted to go on stage, he or she can very easily publish a stream, and there is nearly no delay in that experience. If one of the people in the off-stage section wants to go on stage, then they can be migrated into the SFU into sort of a low latency environment. So that's sort of a high-level overview of some interesting architectural approaches to solving interactive broadcasting. And I don't want to go into too much detail with all of these architectural considerations, but my objective is to give you guys all a flavor in terms of what to think about as you are thinking in terms of enabling interactive broadcasting. So the first consideration is something called simulcast. And simulcast is sort of natively supported by WebRTC implementations, but one big problem you have with sort of in a large-scale interactive setting is you don't want the quality of a subscriber to sort of affect the quality of the publisher, right? What you want to be able to be in a position to do is for the publisher to publish as best of a quality as it can, which each subscriber selectively figuring out what he or she wants to sort of subscribe to. And this all needs to happen pretty dynamically. Here's an example of P1, and P1 is using simulcast to pump multiple spatial and temporal quality layers. And there are 2 subscribers, and each subscriber, depending upon his or her sort of network conditions, can choose to adapt and subscribe to higher or low quality sort of sessions, right? Low quality streams. And so simulcast is crucial to get right and get optimized in sort of a large-scale, sort of interactive broadcasting session. And this also helps with mobile networks, where because of mobility, you could be moving across different networking environments, and the entire experience needs to be optimized. This is just, I'm sorry, the graph may not be very readable, but at a very high level, the violet line on the top is basically the bit rate of a publisher as the number of subscribers increases. And the other 2 graphs are sort of non-simulcast scenarios. And if you actually look at this graph, as the number of participants in the call increases, the bit rates with respect to simulcast is relatively constant. So the publisher is publishing as best as it can, Whereas in all the other scenarios, you see a massive degradation in bit rates as more and more participants join, right? And obviously, if you're thinking about large-scale interactive broadcasts with hundreds or maybe thousands of participants, it's really important to get this right. And so simulcast is one example of network adaptation. And similarly, there are other examples of network adaptation. For those of you who don't know, WebRTC actually provides this mechanism called RTCP, and it's a simple mechanism to provide feedback. In a one-to-one call, it's all relatively straightforward. You have a publisher, you have a subscriber. If the publisher is sending more data than the subscriber can handle, the subscriber merely notifies the publisher, hey, slow down, I can't handle anymore, right? But think about what happens when you have, like, I don't know, 10 people in 10 subscribers to a stream. 5 of them say, send me more data, I have a lot of bandwidth, I can handle it. Another 3 people said, no, don't send me any more data, I actually slow down. And 2 of them say, don't do anything. Like, how exactly do you adapt to RTCP? Sort of an important consideration to think about in a broadcast call. And even if you handle all of those, there are very simple things like data volume. Traditionally, the amount of RTCP feedback should be around 5% of media traffic, right? This is an example of a graph which shows the ratio of RTCP feedback to publisher bitrate, right? And when you reach about 80 concurrent subscribers or viewers, the amount of RTCP feedback you are sending back and forth is equal to the amount of media data you have. And the amount of data, RTCP can even flood the stream as you have more and more subscribers. So the point I'm making here is it's really important to actually think about RTCP termination and how do you handle feedback in a multi-party scenario. Not going to go into a lot of detail here. This is another representation of the same model. This is how many PLI requests came in when the number of subscribers increases, and PLI requests are basically requests for iframes. And so again, regardless of simulcast or not, as the number of subscribers increase, you will have a corresponding increase in these requests, which all need to be handled intelligently. So I'd urge you guys, as you're thinking about it, to think about RTCP feedback and termination. And recording. So a lot of these broadcast calls, it's an interesting experience, and most people want to record that experience, the interactive experience itself, right? You want to record that experience. Let's say you're talking to a cricket fan. You got the ability to go live. You got your 15 seconds of fame. You want to record this, upload it in YouTube, what have you. So recording of that content is sort of an interesting, important bit. Again, not going into too much detail, but there are multiple mechanisms of trading off latency and where you record. One way to record would be to record a file directly off the MCU. In this case, you get a mixed stream, and as soon as the call finishes, you have access to the recorded data, right? But this might be more expensive because it's computationally requires more resources. Another mechanism to do this could be you record the individual files coming off the SFU, and then you send it to a slightly offline sort of merging transcoding unit. This is much cheaper, but obviously you'll have to incur a certain amount of delay. As soon as the call ends, you don't immediately get access to the recorded file. Again, this is to give everybody an idea in terms of, there are multiple architectural approaches which need to be thought about when trying to build large-scale interactive experiences. And finally, mobile. Obviously, in these sorts of experiences, you can't afford to sort of ignore mobile endpoints. Mobile obviously has limited screen real estate. The question is, what's the best way to enable these from a UX perspective? Maybe you have a mixed stream coming into a mobile device. Maybe the client mobile device actually switches across different streams depending upon which active participant is speaking. There's a bunch of very interesting factors to be thought about in order to enable real-time interactive broadcasting from the mobile endpoint. And add to that, battery, CPU, network adaptation, right? You might want to think about, can you take advantage of hardware acceleration on the mobile device? How do you do sort of network tolerance, rate control, and bitrate adaptation differently in mobile devices than in regular endpoints. How do you deal with connectivity by reconnects, so on and so forth. So there's a bunch of interesting sort of dimensions which is important to think about in the context of mobile endpoints. And so that's pretty much the end of my talk. But the message I'd like to leave you guys with is interactive broadcasting is absolutely the next frontier of real-time communication. And there's a whole bunch of interesting experiences which are going to be built, which fundamentally change the way audiences basically not only generate content, but how they engage with content and how content is being distributed. So it's one of those very sort of fascinating areas of real-time communication, and WebRTC is actually helping drive that change. So on that note, I'm happy to take any questions.